Whoa. Okay, guys. This is lesson 2. So you just worked on figuring out patterns, which one is exponential, which one is linear, what was the rate of change. So remember, exponential means that it just shoots up rapidly. It's such a rapid growth. And it's usually associated with change in having to do with multiplication. So it increased by multiplication. Now linear is just a nice steady increase. It doesn't change. It doesn't do anything drastic. And that increases by the same number with regards to adding. So not multiplication, you're adding. Now rate of change is how much changed in between it. What is it? Is it 2 pieces changed, 3 pieces, 4 pieces, and so forth? You just figure out what number. So multiplied by 2, multiplied by 3, was it added to 1? You just have to figure out what's the difference between these numbers. And so now we're going to look at big things differently. We're going to actually graph these sequences that we just looked at actually. So I hope that this is review, and I hope that if it's not, that I will be able to catch you up and give you a little refresher. So this is probably one of my favorite things. It's like graph paper, and it's like I can never say the name. It's like a Cartesian plane. But this is how we graph things all the time. There's 2 important things of this paper. There's an x-axis and a y-axis. Now we need to know where these are in order to actually plot points and create a line or an exponential line. So a linear line or exponential line, that's what we're trying to create. So does anyone, I wish I was there, does anyone remember what an x-axis is? So the x-axis is always 100% of the time, no ifs, ands, or buts. The bottom line right here, this is always the x. This is always the x. And I'm actually going to pick this little guy up and move him over here. So this is the x line. So if this line right here, this bottom line is the x line, where do you think the y line is? I hope everyone yelled, oh, it's right over there, right here. So, there we go. That was our first step, finding our x and our y. So we know this one is our, I'm going to keep moving around just because I'm thinking. This is our x-axis, we call it, and our y-axis. So you'll notice a new term, y-intercept. So when we create this line or exponential line with these numbers, so pretty cool, I love doing this, we're going to try to find where does our line cross this x-axis. That'll be called our y-intercept. And the last thing, boundaries. Is there any boundaries, or is it go on forever? So depending on if it's linear, exponential, we're actually going to know where it starts and ends. So, or if it's exponential, it's never going to end. It's just going to go on forever. Kind of like the number pi. So let's get a little dot. I'm going to use this. I know you can't see right now, so I'm going to make it, let's pop it up with red. And red. Okay, so here's our first dot. I'm going to try to be super precise with this. Oh, it has to be smaller. So our first one is x is 0 and f at x is 9. So what is this f at x? Does anyone know? Math people, let me tell you guys something. Math people we think we're super fancy. Alright, now we're not the best spellers sometimes, so in order to overcome that, I think, we create these terms. So instead of saying y, they said f at x, which just means a function of x. So y is something that is always in regards to x. X is always the most important thing. If you don't know x, then you don't really have a function, you don't really have a purpose. You can't really graph it. So this is me connecting them. So y is always stands for a function of x. And I think why they do that is because, yeah, you know what, I'm not going to get into it. I was going to go, there's a z-plane, but there's not any of the points here now. Anyways, so this is our x coordinate. So this right here, these numbers are going to tell us where on the x axis are we going to place it. And then our function of x side is going to tell us, well, how high up do we go? Right, so the x's are down here. These are the x lines. And the y lines are these ones. So our first point is 0, 9. So our x, we got to go to the 0 position, which is this position right here. And it tells us to go up by 9. So 1, 2, 3, 4, 5, 6. Well, let's count. Damn it. Oh, sorry. 1, 2, 3, 4, 5. Oh, wait. Those 5, so 9's right here. Okay. So let's make another one. Well, bam! So our next one is 1, so we got to go to the 1, and we got to go up only by 6. So we just got to make a tiny dot, put it there. Our next one is x is 2, and we got to go to the 3. What are you guys thinking? Is this a linear or is this exponential? What are you guys thinking? What are you guys thinking? You should already have something in your mind on what it's going to be. And you could actually already have the rate of change in your mind. Ooh, look at this one. So we were at 0, we moved to 1, and we had to go up 6. We moved to 2, and we had to go up 3, like it says. Now we're on 3 right here, and we have to go 0 up. So that's kind of weird. So remember, 0 up is we're just going to leave it on here. And what do you guys think about this next one? -3. How do we graph that? How do we graph that? And with this picture, can we really graph it? Ooh. So let's see. Wow, my dots were not consistent. So we need to be on, oops, hope someone caught that. I didn't put it around. We need to be on x is 4. Now, this -3, does that mean I go up here? Not quite. When we're dealing with this section of the graph, we're actually in the positive. So right here, since this was 0, remember negative numbers are below 0, so we have to find a place below 0 that would make sense. So I'm going to pop it right there. That looks like it makes sense to me. Now, what do you guys think? Is this a linear or exponential line? Let me change colors because I can. Something happened there. Bang, bang, bang. It doesn't like me, so we're just gonna, I don't even know what that blue thing is really, so I'm just gonna leave it. This, what do you guys think? I hope everyone yelled, it's a linear line. So, if you notice even just here, how does it increase, or how is it going? Obviously we're going down, we went from 9 to 6 to 3. So, how much is it going down each time? Well, if we notice, it is going down a whopping, a big old whopping. Why is it like, it's changing. Let me just. From here to here, how much is it changing? Sadly, that doesn't want to work. This is going down by 3. So remember, whenever we're showing down, we have to use a negative number. And from this one, it's going down by 3. And so forth and so forth. So our rate of change is down by 3. Or you can put, if you don't want to make a sentence, -3. Now, again, this is linear. Linear because I know it's not a plus, but it's the opposite of plus, which is subtracting. We're going down. And remember from yesterday, I forgot to mention if you're adding and subtracting, that means linear. So it's a linear one. Now the y-intercept. So where does this line cross the y-axis? So there's two ways to find it. You can just look at your graph and you're like, oh, well, it crosses the x-axis, the y-axis at 9. We went up 9 spaces and that's where it is. Now a little cheat. Let's say you want to find this before we actually made the graph. The way to find the y-axis is wherever, or I should say whenever x is 0, then that is then the y value is the y-intercept. So right here, x is 0, the y, or the function, is 9, and that was our y-intercept. So that's a little cheat. Now, are there boundaries or places on the coordinate plane that the function will never reach? Actually, at this case, we're just gonna skip this question for now, and for the other ones, you'll notice. Oh, well, it's not really giving me. Oh, there it is. You'll notice for the rest that it says that don't do that. Okay, just do it normally. You know, plot all these. You know what, for fun, haha, because I love actually plotting points. It's one of my favorite things. Let's plot the next one. So 0 and 1 is our first one. So let's get a circle up in here. So again, oh, that's kind of big, eh? When our x is 0, so remember this is our x, this is our y, our, come on little hand, our f at x or our y is 1. So we're going to put it here. You know what, let's actually put, oh, it's super tiny. Hopefully you can see. Let's put our x, and doesn't want to do it anymore. And let's put our y in, just so we remember. Alright, our next one, x is 0, oops, sorry, my bad. X is 1, while f at x is 2. Okay. So when x is 1, f at x is 2. So it's not quite 2, so let's fix it. Now, I hope you kind of have an idea on if this is linear or exponential. So now when x is 2, y is going to be 4, or the function of x is going to be 4. So x is 2, and 4 is up here. Oh, so if you notice, we did kind of a jump there. So that should give you actually an idea of whether this is linear or exponential. Now when x is 3, y is 8. Ooh, look at this. We jumped a lot. So we're growing really fast. When you grow really fast, are you linear? So x is 4, and 16, 5, 10, 15, 16 is right here. If you're linear, you only grow at a nice steady pace like the last one right here. We decrease at a nice steady pace, nothing changed, but this one, if you notice, it kind of does a jump. And if you remember, that is actually a oh right, the arrows don't work. I can't put a line through it. This is actually exponential. Exponential. Now let's check the other way. Remember, we didn't do graphing yesterday, and we were able to figure this out. So from 1 to 2, we increase by 1, technically, right? So let's write that in. We increased, so plus 1. Now let's look at 2 to 4. Did we increase by 1? No. What did we increased by 2? Now, for linear, they need to be all the same. They need to be all the same. So I can't put this and call this correct. And say, oh, it's linear, look, it's growing. No. These, in order to be linear, these numbers have to be the same. Right now, they're not. So what number could we put there? Since it's linear, we know we're not adding, we're actually going to be multiplying. So what number can I multiply the same in order to get this to make sense? So what number can I multiply 1 by to get 2? At the same time, that same number is multiplied by 2 to get 4. So think about it in your head, and it has to be 2. There's no other number. It has to be 2. Now let's see if we're correct. So 4 to 8. If I multiply 4 by 2, what do I get? 8. Okay, sweet. I think we're on the right track. And let's try the last one. If I multiply 8 by 2, will I get 16? Yes, I will. So look, we're right. So the rate of change is times 2. And I'm going to write increase because we are going up. We didn't decrease by 2. All right, now our y-intercept. Remember, there's 2 ways to do it. Right here, if I just look up on the graph where x is 0, my y-intercept is 1. So it's quick and easy that way. Or I look at the graph and when x was 0 right here, it was 1. Okay, you're going to have the rest of the class to finish this. Good luck. And you got this.